we will look into the dot product of two vectors. So let's say we have two vectors A and B. The intermediate angle between them is theta, x-axis and y-axis here. So if we say the dot product is f, which is a scalar, we write it this way: this is A, this is B. It means the dot product. And the expression geometrically, we say that magnitude of A, magnitude of B, and cosine of the interior angle, which is theta. So AB cos theta, that's what the expression is for in terms of in geometrically. Now if we say algebraically, we know that it's said that we can say the x component, any vector we can divide it into two components, one is x and one y. So one x component and one y component we can divide it into. So let's say this is x component, so we can call it ax, and this is here up to there, this one would be y component, so we can call it ay. So, and similarly we will have bx up to here, of course the whole of it, and then by will be just that would be by. So in terms of algebraically, it's written that ax bx plus ay by. So we will derive this one using the geometric product. So the geometric expression. So geometric expression actually means if we say ab cos theta, it's actually, we can call it as a b cos theta. That means the component of b in the direction of a times the product magnitude of a. This is what the dot products means basically. So this is the component. When we say b cos theta, that would be the component in the same direction as a in the direction of b, same direction of b in the direction of a, times the magnitude of a. So that's what the dot product is. So that's why we have like this. This is the physical interpretation of the dot product. So if we start from this one, which is, sorry, so this is the dot product algebraically. So I will geometrically, sorry, so I will write it again, cos theta. Now if I look back into the picture and if I make an observation, I can call this angle, the angle that B makes with x-axis, as theta B, and the angle that A makes with x-axis, theta A, we can call this. So this is theta A. We are just naming these two angles, we just identifying these two angles as theta and theta B. So we can see from the diagram that theta is, the whole thing is theta A and this part is theta B. So theta is theta A minus theta B. That's what theta is. So we can write it AB cosine of theta A minus theta B. So we can write that. Now we can expand this one in terms of cosine rule. So that will be cosine of theta A, cosine of theta B, plus sine of theta A, sine of theta B. So that will be the, once we expand it, it will look like this. So now if we carefully write it, what we can do, this becomes basically AB cosine of theta A. So cosine of theta A, cosine of theta B, plus AB sine of theta B. So getting theta A and sine of theta B. So basically getting rid of the bracket. Now we can write it this way: A cosine of theta A and B cosine of theta B. So I am rearranging, nothing else, I am just rearranging it. Similarly this one we can write A sine of theta A times B sine of theta B. So all I have done is I have written this A with cosine A and written this B with cosine B here, and that's what I have done for here, A with sine theta A and B with sine theta B. So if we do that, now if we look at this term A cosine theta A cosine theta A is actually AX, because this is the angle theta A, and this is A. AX is the component of A in the direction of x-axis. So AX has to be A cosine theta A, and AY will be A sine theta A. Similarly, B, I will write here, so maybe I don't know, maybe I will write here. Similarly, BX will be B cosine theta B, and BY will be B sine theta B. So it's, the pen is not working, or maybe the screen, anyway. So B sine theta B. So this is now becoming obvious that this part is AX, this part is BX, and this part is AY, this part is BY. So it becomes AX BX plus AY BY, which is the geometrical product. So all I have done here is trying to find the this is the algebraic product, sorry. So that's the vector dot product of two vectors expressed in terms in algebraic terms. So basically I have started with the geometric expression and derived the algebraic expression of dot product.